Hello, ROS developers. How are you doing? I'm sorry for the delay here in the transmission. Crazy times here at the construct. Let me see. Oh, you cannot see me. So anyway, here it is. How you doing, guys? Welcome to a new ROS developers live class. I'm happy to be here. Today we are going to work with Cartographer. You know, the program of Google that has created to allow robots to create maps, 2D and 3D maps. We are going to see a very simple implementation and example, okay? So don't get too much excited, and I'm going to explain you why. But before everything else, so I would like to say hello to the people on the chat. I see that there is a lot of people here today, and then just want to say hi to Mindaugas. That he says he's starting by asking a question: is it possible to add SLAM to Turtlebot to Maze OpenAI example? Yes, but it depends what you mean by adding the SLAM into the OpenAI. So what do you mean? What do we like to do? Then we have Guillermo Rufino. Hello, ROS developer. And then Matthew Hinton. Hello, Matthew. Happy to see you again here. Del Capute. As always, here, and all those people were already ready before we even started some minutes ago. And Marcus, hello Marcus, how you doing, man? Themba Ramococa, and then Platanecat, hello. Gaser, also. Amon, Betty. Then we have Rishav that says, I'm in ROS, I'm very excited to learn. Very good, that's the attitude, Rishav. And Sri here, Rob, EKX00, Rishav, okay, said it already, so you have started there to talk. So, hello everyone. So all the ROS developers are welcome here to the live class. And how does it work, the class here? So what we are going to do is to learn about a very specific subject of ROS. Today is Cartographer, you know, the program that allows us to create maps. And then we are going to do a practice about this Cartographer. So you are going to launch Cartographer with me. You are going to configure, launch it, and do a small map. And then we are going to use this map for navigation inside the ROS project, and using a simulation of a Summit XL robot. So all of you are going to practice with me. How is it possible? Do I have to have my computer installed with any software? No worries. We are going to use a web browser to do that. So what I'm going to do is to share with you, just in a minute, the link with containing a project. This project is a ROS project containing all the code that you are going to launch with me. Code, documentation, simulations, everything is integrated there, and you only need a browser to do all this stuff. So we have developed this environment for you, for learning, and for not only for learning, but also for doing practice, for programming for robots, whatever you want to do with ROS and robots, yes? So I'm going to share this link with you on the chat in a minute. You click on there, and then you get all these projects. And then we start step by step all together. Then remember to use the chat to ask questions. Whenever you feel stuck there, use the chat. You don't have to use it if you don't want, but it's your option. So don't get stuck. My main interest in all those classes is that you learn. So if you get stuck, I will do my best. We are a lot of people. We have to move on, but I will do my best to help you on this. And yeah, basically I think that's it. So we know how to work there, yeah? So let's continue. I can see that more people is coming. So you can say hi on the chat. If you don't feel like it, you don't have to. Just stay here with us and learn a lot of ROS. So I see Mingy has arrived. Andreas, Danny Subal. Question for later. Can you feed Cartographer with data from multiple LiDARs? Yes, the answer. The answer is yes. So you can see that you can provide this. Then Nele Yashul Kumar says yes. Oh, so he answered already. Very good. And all the people, Guillermo Rufino says yes. Maybe many, in fact, exactly. Yes. Okay, great. So let's go. Let's start. So let me share with you my screen, and so you can see what I am doing. And let me here. Okay, go myself to my screen, my own screen. Here it is. So this is the project that we are going to open in a minute. Okay, that's the documentation that contains the project, and we are going to follow all this for today. Then let me show you my list of projects is here, and I'm going to share with you this one. This is the project for today. And in order to share a project, you are going to have a section like this in a minute. You're going to reach your section with your own project. So in order to share a project, you can share with your colleagues by clicking here on this icon, a sharing icon, and then selecting the link. So you get the link, and then I'm going to put this link into the chat. There it is. So you have the link of my project there. Then the only thing that you need to do is to click on that link, and by clicking on it, you are going to get a copy of this project here, of this one. So if you click, you need an account on the ROS Development Studio, a free one, just a free account. Create a free account and then click on that link. It will generate this project for you on your area. Then once you have that done, then you should select the project here by clicking on open and then open again. And then it's going to open the project. So it's going to show this screen loading and so on, and it's going to load the project with all the content. Remember that the project contains documentation, it contains code, ROS code, I mean, well, any other code also it can contain, but we are here interested on code. It contains data sets. If you want to include data set, it can contain data sets. It contains simulations. And just recently, we have added also to the content of a project web pages. So that's another thing that everything is packed inside the project. And I'm waiting here for opening it. Then maybe it will take 1 minute or so for you also to open. But that's it. So here it is open, and here I have the project for today open. This documentation is going to open automatically for you. Then if it doesn't, or you close it by using the icons here, then just go to tools and then select Jupyter Notebook, and then you are going to get again to open the notebook, you are going to get the option for that. Okay, so let me see if everybody is with me. So I'm about to start on this. So let me check that everyone is following on the chat. Says, so we have Guillermo that says, Cartographer can subscribe to one topic per laser. Yes, that's right. And then let me see. Plantanicat says that he used data from Auster LiDAR. Very good. I installed the Carto but got failed on creating map. Okay, so you are talking between you, but that's very cool. Yes. Okay, so I presume that all of you have reached this point, that you have opened it. Let me know if it's not the case, because we are about to start. So I have to tell you one thing though, so I have to be sincere with you, and that is the first time that I have used Cartographer, I mean, sorry, not Cartographer. Carto with K is another package. So Cartographer ROS, that's the first time for this live class that I have used it. So I don't have very much experience on this. So because of that, we are going to have today here very basic class about Cartographer. So I cannot teach you very much, but I can give you an example, running example, and some understanding of the structure of how it works, Cartographer, and how to use it for creating a map for your own robot. And then you can use this map for doing localization and path planning, as if we were using Gmapping, for example. Like in the previous live classes, we have been using Gmapping. Or you can use also Carto with K, Carto is another package that is available in ROS for creating maps also. It's another option. So that's the thing that we are going to do today, okay? Very basic. We are going to learn what is Carto about. We are going to create a configuration file for Carto. We are going to see some of the parameters that work, and then we are going to create a map. And then finally, we are going to use this map to localize in the area and make the robot move around using this map. And most of the code is already provided, okay? So you and I, we are only going to work on creating the launch files for launching Cartographer for a specific robot and the configuration files. That's what we are going to create together, okay? Are you ready? Let me know if don't on the chat. Let me check. Then Danny Sobal says, Guillermo Rufino, so you need to add the 2 lasers to Cartographer and that's it? It's more straightforward than on Carto. Yes. Okay. Here in this class, we are going to use only a single laser. Okay, so I don't know how to add. I know that it's possible to add several lasers because it's a configuration issue, but I cannot teach you today here how to do that because I haven't tried and I don't know. So yeah, so that's the situation for today. Okay, just to make clear and about the expectations. But anyway, we have a lot of stuff to do and a lot of things to learn still. So let's go for it. Then, if you have launched this project, you have here some indications why it's important to learn about this topic, about Cartographer. I mean, about a program that can do maps. So it's very important because by doing maps, the robots can localize in an environment. That means that the robot can understand where it is in an area. For example, in a robot at your home. So where is this robot, in which room it is, and how does it have to go in order to reach the kitchen? What is its location related to the kitchen? So that's why we need to learn about Cartographer or any other mappers that allow us to create a map. And for creating a map, basically the most basic stuff is a laser and an odometry system. And that's provided by the robot itself. In the robot of today, we are going to use this Summit XL, and then it has a laser on top and also has an odometry system built in. So we are okay in this case. Then what else? Some requirements. Well, before, let me tell you that this notebook was prepared by Christian and myself. So, but most of the work was done by Christian, so he deserves the credit. Christian is the intern at the construct at present, and he is helping with the preparation of the live class and doing all that stuff. Then requirements for understanding this is the basics of Linux, because we are going to issue some commands, very basic, very simple, but that's necessary. If you don't know about Linux, let me recommend you this free online course that we have here. And then also there is a basic knowledge of ROS that you need to have. And of course here you have another online course that you can take in order to learn about ROS. The basics of ROS, topics, launch files, config files, create packages, etc. And then you need to understand about ROS navigation, how the ROS navigation stack works. Again, here another course for this subject in case that you don't. So if you don't, then I recommend you to do those courses. But anyway, I'm going to guide you today here, so you are not going to get lost, too much lost, if you don't know about those subjects. Okay, so don't worry too much. Then here are some instructions about how to use the ROSjet, already explained to you. And for today, we are going to use this simulation. So let's launch it first. What do we need to launch this simulation? We are going to go to Simulations menu. Okay, in my case, I have to change because I was doing tests before. So let me go back again. So if you are fresh new, you have opened this ROSjet fresh. Then you go to Simulations, and then you will get this screen. So today we are going to use to launch a simulation that is already included by default in the ROS Development Studio. So we don't have any specific launch file to execute, but we are going to select a wall, an environment, and then we are going to select a robot to launch. And then we are going to start the simulation. It's going to combine both things. So here on the wall, click here and select the Tiago wall. The Tiago wall is this one that is here on the Tiago small office. Tiago small office. You can also type here in order to filter. So you go. So here it goes, and then I select that one. Then I go to the robot, choose a robot. The same thing. So we have many robots. You can select some of them. Then let's select the Summit, SU Summit XL. So this one. And then press Start Simulation. So this is going to launch the simulation of the Summit XL inside the environment of the Tiago. Those are simulations that we provide already on the ROS Development Studio. And in case that you're interested to download it, we have a public workspace, a public Git, where we have all the simulations that we have here as open source, of course, and then you can download it to your own computer in case that you want to use them, or I don't know, modify them or so. And here we have the simulation of the robot and the environment. So yeah, so the environment is there. Then it's been white. So this sometimes happens that the textures get like this. So I'm going to press the icon to reload the image. So now we get proper texture. Yeah, sometimes so some things we still are things in progress, work in progress. Okay, so we have that. Then let's go and let's start with the meat. Okay, we have the simulation. We are going to use this robot in this environment to create a map. Then let me check before going to Carto if there are any questions there that I cannot answer. Then here I have some from Danny. He says no problem, one is fine for now. Okay, great. Yeah, so we have to check that how it works and test it in multi-laser robots. Then Erop says, can I create 3D map with depth map, for example, and use it for autonomous navigation? Yes. And what packages can help me with that? So Carto can create a 3D map. In this live class here, we are going to learn only how to create a 2D map. Okay. Sorry, guys, I told you at the beginning that this is well, we cannot do everything on a live class anyway. So this is the first time that we are working with Carto in our team, and then we just prepare this small introduction to that. So creating 2D maps. But you can create 3D maps with depth image. Okay, Christian is answering that. Great. Okay, let's continue. Then, so Cartographer can create maps in 2D and 3D and can be used for mapping and for localization. Actually, localization is work in progress from the Carto team. So you cannot, with the current version, at least that we haven't found how to do that localization. So what we are going to do here today is to create the map using Carto, but then for the localization part, we are going to rely on AMCL from ROS, the AMCL package for localization. But you can create maps in 2D and 3D. Then how does it work? Well, here we have already installed Carto and all the packages that it requires in order to make it work. So you don't have to install. So because that makes no point. In case that you need to install in your own computer, you have here the instructions in this link. That is the official documentation. And then here you will learn about building an installation in this case. Okay, but that's not what, we don't need to do that, because if you go to the IDE on ROSDS, let's open the IDE and see the files that we have included. Go to Tools, on the top menu, go to Tools, then select IDE. Now we have this IDE that is opening, this new window. And here you can see all the workspaces that we have in in a ROS yet, in this specific ROS yet. So if you go to the Catkin workspace, which is where we store all the content for the code for the robot, all the content, all the programs that will run inside the robot. So you can see, well, some instant isolated, and then we have the source here, where we have the Cartographer and the Cartographer ROS, and also the Ceres solver. So all those three packages were required in order to get Cartographer working. And those are the instructions that you can get here. Compiling, so on. So everything has been compiled, installed, so it's already running. Then, how do you launch Cartographer for your robot? So I'm going to show you a very quick and dirty method. Not dirty, I mean, it's quick. It's just very quick, and you can use as a template for any other robot that you would like to use. Okay, so basically, launching Cartographer requires to write a configuration file for Cartographer. And this configuration file has to be written in a language that is called Lua. That's the format of this configuration file. Here you have one example of configuration file. This is an example. And you can get some other examples here if you go to this directory. Okay. So in this directory that we have in our IDE, also here is in source, so Catkin workspace, source, Cartographer ROS. Let me open here. Then configuration files. Where is it? Well, Cartographer ROS again, sorry. And then configuration files here. Then, okay, so no, it's not that one. Cartographer ROS, source Cartographer. Let me see. Wait a second. Let me see if it's on the install. Here. Cartographer ROS, configuration files. Okay, so yeah, so you will find more configuration files. I don't remember why we don't have more. We should get them here. We should get them here. So all the examples that we have for other robots. Well, anyway, so then forget about that. So forget about that. It is supposed that we should get more configuration files here for different robots as different examples. But I don't know why we don't have them here now. Not even on the installation. On the installation we have the one of the summit, but not, yeah, so only the one of the summit. Okay, so forget about that, sorry to confuse you. Then yeah, but well, in this directory you should get the configuration files for these Lua files that should be specific for your robot. So you have to create one Lua file, config file for your own robot, and also you have to create one depending if you want to make the robot do a map in 3D, or if you want to make the robot create a map in 2D. Here we have included two examples from the guys of the Cartographer. So those were provided already by default. They should be there in the configuration files, but I don't know why they are not there now. So yeah, so those are the typical ones. Okay, so we are going to construct one of those in a minute. Actually, we are going to construct one that is more closer to the one in 2D. So important points, let me explain you that later. I think that explaining this here while we are not creating ours is not important. So let me explain you about those parameters that you need to include and the values in a minute. So what we need to launch a Cartographer, as I mentioned, are two things. First one is the configuration file that we have here, one configuration file. And then we have another one that is the launch file. We have to create two files in order to launch Cartographer. And then in the Cartographer launch file, then what we indicate is how to launch the different nodes from Cartographer that we want to launch, and provide to Cartographer with the proper topics so that the node can get the scans and so on. Okay, so we are going to see in a minute. So this is just an introduction on how it works, just to give you an idea. Now let's go on, let's create ourselves this for our robot, the one that we have launched on this simulation. So the first one is, let's create this configuration file for our case. And what we are going to do is to create a package that is going to be called testing cartographer. And then create a config and a launch file, a launch directory inside this package where we are going to install our config and our launch. So let's go. So first we need a terminal. So for that we go to tools and then select the shell. And here we have to go to the Catkin workspace and src. Remember that whenever you create a package, it has to be inside the Catkin workspace as src, I mean on the source directory. Then here let's use the command catkin _create _pkg. This means let's create a package of ROS. So this is basic ROS, that's why I haven't written the command there on the notebook. Just follow the instructions. And then the name of the package, that is called testing _cartographer. So there it is, we have it created. As you can see, it has appeared here also on the IDE, which is there. So we will go to the top. Let me see, where is it? Oh, that's the install. This is not here. It's Cartographer ROS. Let me close some things here. This is the source, Cartographer ROS, source. Testing cartographer. Here it is. Okay. Then let me create inside there that package. Create two directories. So one, if we go inside the testing cartographer, then let's do a creation of a directory that is called config, and another one that is called launch. And we are going to put our config and launch files there. So now I'm going to use the IDE to create a new file, the config file, inside the testing cartographer config directory. So I do a right click here on the IDE and select the option new file. And this new file name is going to be called summit.lua. Okay, please indicate the extension as Lua always. You can put another name, but the extension has to be Lua. Then now we are going to copy the content of this cell here. This is the configuration file that we are going to use for our Summit robot. So select this content. You can select like this or do Control A. It depends on your options. So let me see. Here it is. Copy and then paste here. Okay, so let me see. Here it is. Okay, so let's have a look at the important parts here. So there are a lot of of config parameters, but and then you can check all of them here in this link that I have put here. So you can go later and check all the descriptions for all the parameters. What I'm going to go is to just to describe the ones that are more important and the ones that you probably will have to modify for your own robot. So the first one is this one, is the map frame. So you can copy this same structure for any other robot. I mean, a differential drive robot or kind of differential drive, a wheel robot with a laser and publish odometry. So you can use this template and just modify a few parameters. So the first one here is the map frame. So this is the name of the frame that will publish the map, in which frame we are going to measure the distances in the map. So that's the map, that's clear. Then the tracking frame, this is the frame, the name of the frame that you want to locate inside the map. So that means the center of the robot most of the times. Okay, so that's why we have put the base link. Then the publish frame, really, I read this description several times, and I was talking to my colleagues about this. What's the meaning of this published frame? And actually didn't understand quite well. So the documentation doesn't explain very well, and just put the base link also as the default one. That usually works. And because I didn't understand really what is the meaning of this published frame, so just took the frame by default. That indicates the documentation. Then finally we have the odometry frame, that is the odom here. Then I wanted to explain you about the other ones that are here, like the number of laser scans. So this is in order to the question that, who is his name? Let me check on the chat. So he was asking about how many, if we can subscribe to many lasers. I don't remember, but somebody asked here on the, I think it was Danny. He was asking about, yes, so Danny, so you were asking, so here it is. So here is where you indicate the number of laser scans, but my answer to your question is that I didn't know how to, I don't know how to provide all those topics. Okay, so all the topics, so I know that we have this parameter here to indicate the number of laser scans, that in our case is one, only one here. But I don't know how to provide these other topics. So I don't know yet. Then here is another parameter is the multi-echo laser scans. This is for a very specific type of laser scans that can provide several readings because in situations of a window or some crystal there. So in our case, we are not using multi-echo laser, so it means 0. Then this number of subdivisions also, this is based on those multi-echo lasers, you can have several measurements per single laser scan. So how many of those you would like to have? In our case, because we don't have that multi-echo laser, we have to put only one. And then number of point clouds, because we are not using any point cloud, then we have to do a 0. In case that you would like to use a 3D map, you will have to put here the number of point clouds that you are providing. So those are the most important ones, that parameters that you will have to modify for your case, for the case of the of your robot, or your specific robot. Then another one here on the bottom is about this trajectory building mean range and max range. So those are the minimum and maximum rate distances that you would like to take into account from the lasers. I mean, when a laser measures something more than 4 meters away, we are not going to take that into account. When it measures less than 0.1, also, we are going to discard that laser. Basically, that's it. And yes, and then the rest of the things you can leave like that if you want to build a 2D map. And I'm sorry that I cannot provide you with more details. And so that's a live class of today. So that's what we can provide you only. Sorry for that, but that's good enough for us to create a map and also make the robot localize and use the map. So let's continue with this, unless somebody has any question. Let me see. And here we have the questions for some Rudy that says, does Cartographer work better than Gmapping for loop closure in mapping? It looks like yes. So that's what I have read on the reviews, that it looks better for that, and also for bigger maps. That's what I have read, but I didn't have the time to test that one, so I cannot confirm that. Then Adam says, sorry for being late, but I'm here. Hello, Adam. Welcome. Okay, so you are late, no problem. You have to go to the back of the class because you are late. Stay there, but go and grab the ROS jet and start practicing with us. So happy that you arrived at the end. Then Salmudi says, Okay, so Christian is answering here, and then Guillermo say if you put num laser scans to 2 equals scans to laser 1 and laser 2. Oh, okay, that's great. So thank you for this information, Guillermo. So we didn't know that. So that means that you we'll have to provide, if I understand, we'll have to provide the base name, let's say that is laser, and then it automatically looks for the others, for laser, for _1 _2. So we have to provide those in that structured manner. Okay, makes sense. So actually the same thing was, the same mechanism was applied in the multi-mapping system that we created some weeks ago in another live class, that we were doing several robots creating a single map. So all the robots were providing different parts of the map, and then we use the same approach as here. Great. The compute says that he has to say goodbye, but the counselor, please have a look at your Facebook feeds. I had a suggestion for a theme live class or video. Okay, great, thank you, the compute, thank you. Then Empress says, can you give me information about landmark? What do you mean by that? Please elaborate more. What do you mean information about landmark? Then Francis Webb says, hi, I had a question on Gitter and I didn't get an answer. Okay, sorry Francis. So we'll check the question later, sorry. It probably is my fault, you know, so overwhelmed with so many things at the same time at present. But let me ask something. So what was your question, but after we finish the class, Francis? And sorry, I apologize for that. So let's continue. We have our configuration file, and now what we need to do is to launch create a launch file. Okay, so here we have included some information in one way of finding those frames in case that you don't know them. So you can remember that you can always check the TF of the robot. That means is all the frames and their relation, all the frames of the robot and their relations, by using this command ROS run TF view frames. If you do that, then it will generate a PDF file that contains all the frames, as you can see here on this picture. Okay, so here we have a problem with the overposing with the notebook. Okay, so let me minimize all them. Then here you can see a structure of all the frames and the relations, how they are connected to one frame to another, which one is the child of another. So by using this command, you can get the structure of your own robot. So in case that you need it, then check it by this way, by using this. Then let's go and let's create the launch file. For the launch file, here we have the launch file. And for that, we are going to go to our config directory. Here, let me see. Here, where is it? Here on the IDE, I have it here. So let's go to the config to the launch directory and then create a new file. Right-click, new file, and let's call it summit.launch. Then let's copy the content of here. Okay, so we have a problem here with the overlapping windows. So we'll have to check this later. Then here is the example of launch file for a very simple robot that needs to create a map. So let's Control C and then Control V here. And what does it do? Well, it launches, basically it's launching two nodes provided by Cartographer. The first node that is launching is the Cartographer node. And this Cartographer node is the one that contains the SLAM algorithm. You know about SLAM, okay? SLAM is the algorithm that creates the map while the robot is localizing in that map. So that's the node that provides the SLAM algorithm. And then it's launching a second ROS node from Cartographer, that is the Cartographer occupancy grid node. This is the node that is generating the map. So this one here is applying this node here is applying the SLAM algorithm, so it's just doing the calculations. But at some point in time, we want the algorithm to provide us the map. So that's in charge of this second node. It takes the computations inside the algorithm and generates a grid map. You know what is a grid map? Yes, it's these maps that is like an that contains only 3 colors. It contains black for obstacles, white for open space, and gray for unknown space. Like for example, if we go here below, you will see here. So this here is constructing a map. You're going to reach that point in a minute. And then this is a final map that we have constructed. Then, yeah, so that's it. Then also we have here the node for RBS, because we want to see RBS, how the robot is working and how the map is being created. And that's it. The only thing special for the cartographer node is this configuration directory that we are indicating here that has to be in our config directory to look for the summit Lua file. And then also that we have to remap the scan. So the cartographer is expecting to have a topic that is called scan that provides the laser data. In our case, in our robot, this topic is called Hakuyo-based scan. Okay, that's why we need to do this remap inside that node. These are basic things of ROS. I mean, I'm not explaining anything special. The only thing that you need to know is which nodes of cartographer you need to launch and how to specify the config. Okay, so that's it. So that's nothing more. So we got that information. Then the only thing that we need to do is to launch it and create a map. So let's go here, open another terminal. I'm going to open another terminal, and then first we need to source the installation of the cartographer, because we have included here in install. So we have compiled this for you, all this, and installed, and that's why it's already ready for you to execute here. So for that we need to source in order to be able to access the packages. So you can do this source. You have to, because otherwise it's not going to work. Okay, so yeah, okay, but you have to be inside the Kakin workspace, of course. Otherwise it's not going to work. So let's launch it. Okay, now we know about the packages, and now let's launch our testing cartographer, Summit launch, and start doing the map. So ROS launch. You have the command there on the notebook. Also, you can copy from there. Testing underscore cartographer summit.launch. 2 M's here. Okay, so now if everything is correct, then it's going to launch everything for the mapping and the RBase also. So here, well, you can see those errors, but those are actually not real errors, so they don't affect anything to the problem, to the mapping and so on. So here we have the cartographer node that has been launched, the occupancy grid, and the RBase. Okay, so let's go and have a look at the RBase. Where is the RBase? So we cannot see RBase here. Yeah, because RBase is a new window, is a new terminal. It's a new application window. And then in order to watch this on the web, we need to use the graphical tools of the ROS Development Studio. So go to Tools and select the graphical tools. And here in this window, you can see that it appears here, the RBase. There it goes. And I'm going to do one thing. I'm going to detach this from here because too many windows. So I'm going to click this icon here and put it into a new tab of the browser, so we can move between tabs. Remember that you can do that with any window anytime. So let me click here. So, oh, it has blocked, my browser has blocked. Let me allow this. Okay, so let me do it again because it has blocked the tab. So let me do it again. So I'm going to put it there. There it goes. There it goes. So here we have the robot. We cannot see the map. Let's go here to the map in the RBase. Let's go here to the map. And you can see that here the topic is missing. So we have to indicate here from which topic we want to see the map. So let's select map, click there over where, and then we should receive the map. There it goes. And I'm going to remove this part here so we can see better the map. So here you can see that the robot is kind of creating the map. Okay, it's starting because we still haven't moved the robot around the area. Then we have here the summit, all the frames, and also the beginning of the map. Then what we are going to do is to move the robot around here, around the area. Where is my simulation? Let me see, it's here. So we are going to move the robot around the area, and then the map should be created better, containing more spaces. So in order to do that, let's launch the keyboard teleop thing, the keyboard teleop program, ROS program, that allows us to move the robot using the keyboard. For that, we need another terminal. So let me go to Tools and Shell, select another terminal, and then launch the keyboard teleop. So ROS launch, summit, underscore XL, gazebo, then keyboard teleop. Remember that the command is written on the notebook. So you launch it, and then when the program starts, it should tell us the keys that you have to press here in order to move the robot. Remember that if you press those keys, if you want the robot to move, you need to have the focus on this window. So this cursor here has to be blinking, white and blinking. Okay? Otherwise, you don't have the focus, then your keys are not reaching the terminal. So let me press the keys, and you should see on my screen the robot moving on the simulation. Yeah, so I'm moving the robot around a little bit. Yeah, so we go there. Okay, so let me move to the tab where we have the RBS, and you can see that the robot is kind of creating new areas of for example, this area here. That is, and also the other areas, they look like more whiter because he's more sure that this is free space. So you can keep moving the robot around and make the robot create the whole map for you. But as you can see, this can take a little bit. So I have to tell you one thing, that this is a trick. Okay, so this is a trick, is that in this case, usually in all the live classes, in my case, I'm using the same type of computer in the cloud that you are using. But for this live class, I use a Pro 1 version. So here, if you click here on the CPUs and so on, so I'm using a computer type Pro 1 that contains 8 cores. Then in your case, it should say 2 cores. So that's because otherwise it will be very, very slow for me for doing the class, because it can work, it works. So we have, actually Christian has created the code and the demo for that. He has created the map, actually, the final map. He has created completely, and here, which is here. And he has created by using 2 CPUs, but it takes a longer time. So that's that's why, so I have to tell you about this. But this is just a matter of speed. It's not a matter of not working or so. Okay, so just to let you know. Then the thing is that we should move the robot around, and then when we are happy with the whole map, in this case we are here, so here is discovering new spaces, so on. So once you are happy, then you have to save the map. So for saving the map, let me close this keyboard thing. So I'm going to stop on that. And then you go to the directory where you want to save your map, for example, this one in users. And then you have to launch this command, ROS run map server map saver. And then -f, the name of your map. For example, in my case, I'm going to do ROS run map server map saver -f, and then my name is a pre-map, let's say pre-map, because it's just a sample. Then press enter, and it's going to save this map, the current status of the map. So it's going to say something like this. Where can you find this map? It's being created here on this directory. You see pre-map and pre-map yum. So it creates two files. This is the one that contains the graphic, and this is the one that contains some information about the map, like configuration and some coordinates, etc. You can open it, it's a text one. So those are the two files that have been created by that, by your map. And then you can use that map to localize your robot, of course. And how do we do that? Then let me see. In our case, so we have provided a complete map here. And let me think, where did we put this one? Because I don't remember where I put this one. It was, okay, yeah. So I see. So it's on another package that we have included here. So if you go to the Catkin workspace again, so you see all those packages, Cartographer, ROS, etc. There is the package that we have created, testing Cartographer here. And here are the files of the pre-map that I have created. And then we have included for you this extra package that is called Summit Navigation Cartographer. Okay, here you see that there are three directories, launch, map, and source. Inside the map, you can see the Summit map. This is the map that you can see here on the picture. This is a map of the whole environment. We have created it for you, so you don't have to do it later. And then also here, you have created the different launch files that launch the localization, the move base, and the navigation. And use this map. So this is what you have to do. Okay, so this is your homework, because we are going to need to finish here today. So it's almost time. Then in order to navigate with that, so you need to move your robot around the space. This is homework, okay? So you have to do this at home or after the class. So you move the robot around and create the whole map, then save it, and then you have to come here and launch the navigation system. So the navigation system includes the map server, as you can see here, the map server, the localization system, the move base, and the RBase. Okay, so you have here the commands for launching it. But you have to use your own map. Okay, so you have to substitute the map that you have created. You have to substitute the default map that we are using here by the one that you have created. And then make the robot navigate as usual. Okay. So that is all for today. So I'm sorry for today rushing so much and not going so deep on the learning, but today so the class was like that. But I hope that you learn a lot, and then also you practice, because that's new information that we are providing here. So I hope that also you learned something and it was useful for you. So what I would like to ask you is that you support us in the way that you can. How can you support us? Well, you can do several things to support us. If you want to subscribe to our online academy of ROS that we have an online academy. We have many ROS courses for learning ROS and many subjects. And we use the same method as I have shown you here. That is, by using simulation, you are going to practice a lot. We even have a path for beginners where we teach you about Linux, Python before you start with ROS. And we also have some other advanced concepts like ROS2 or OpenAI, industrial robots, etc. So if you can subscribe to that, that would be great. Also, if you don't want to subscribe for whatever reason, maybe you can take one of the t-shirts of the ROS developers, like for example, the one that I have here. This one. Sorry, here. Yes, like this one. So if you would like to have one of those ROS developers, there you have the link for buying. And also, finally, if you don't want to buy anything, but you still want to support us, that would be great. Please give us a thumbs up if you like it, and subscribe to our channel by pressing the bell, so you will be notified about when we publish new videos. Remember that tomorrow we have a premiere. So we are going to publish a new series of videos, which is very, very interesting. It's about creating web interfaces for ROS robots. So imagine that you have to control a robot that is over there, but you want to send some commands or see the status of the robot. But in that case, you will need to connect a computer there, see the RBIS, and connect some terminals and so on. That's a pain. So how can we simplify this so we can create more powerful applications for robots by using web interfaces? Because if we use web interfaces, anybody with any device, maybe just a mobile phone. Where is mine? I don't know. Here is my coffee, so that's good enough. Then anybody with a mobile phone can connect to that robot and see on the screen on a web interface what is the status of the robot, or send commands, request orders, or see all the actions that the robot can do and execute them. So tomorrow at 6 CT, we are going to do the premiere of this new series that is going to teach you how to create web interfaces for ROS robots. I hope that you will be joining us, because the creator of the video also is going to be there answering your questions. And all the team also of the concert is going to be there for answering your questions, so in any case. And that is all. Let me see if you have any questions on the chat that I can answer. Let me go down to bottom, because so many things there, and so I don't know. But before, I'm going to drink. Okay. So here we have Christian is answering something. Thank you for such an amazing session, Agam. Okay, thank you, Agam. My pleasure. Sarmundi says, thank you for the class. My pleasure also. Thanks, some class. Thank you, RZ. Erop also, thank you, Emre. Okay, so he's saying, Emre, yes, I can enable landmark on Lua, but it's not working. I guess I have to add something. Okay, so you've been talking about landmarks somewhere. Let me see where you get that. Yeah, says, yeah, Emre is the one who asked about how to information about landmarks, but I requested, please elaborate more. What do you mean? Then Francis says, I had a question. Okay, Francis is about that. Can you provide the Turtlebot navigation and Turtlebot bring up for melodic? This is Francis' question. And yeah, that doesn't exist for melodic, so you have to download the one from Kinetic and then compile. So you have a system with melodic, go to the Git of the Turtlebot, bring up a navigation, and then download them into your system and with melodic, and then compile. That's it. So you can use it, and I think that they just compile without any problem in melodic, and then you can use it. Then Francis, no problem, I understand. Yeah, Emre says, when we use Cartographer, we can use landmarks, but I couldn't find any information. Okay, so Emre, I'm sorry, I understand what you mean. So there are several ways of doing navigation in a robot. So one of the ways is by doing SLAM with a map, with a grid map. This is one solution, and this is one possible way of solving that is what we have seen here in the class today. So we create a map, and then we match the scans of the laser with the obstacles in the map, and then we compute the probability that is here or there based on this map. But there is another way that is about landmarks. So the robot doesn't create actually a map, a grid map. It creates another type of map that is a map of landmarks and the references, the distances between the different landmarks and the different orientations. So that's another way. And then Emre says that Cartographer can work in this mode. Okay, so I don't know. But it's very likely because it's another, well, I don't know if likely, yeah, but maybe they have those two modes, and I don't know, maybe they are combining grids with landmarks. Also, that's another possibility for navigation, in order to get more stronger localization. So that's possible also. Then it says, Mingy says, oh, it was hidden by the right part of my screen, thanks. Okay, I don't understand that, but it looks like solved. Then Powell says, hi, I do have a problem with Cartographer. My drone is scanning the map and then it jumps a few inches sideways and starts creating a map once again, overwriting the old data. Does anyone have an idea? Okay, so yeah, so that's, I don't know specifically with Cartographer, but that's a very typical error with mapping, 2D mapping. You are talking, I presume that you are talking about 2D mapping, okay, not 3D mapping. Then with 2D mapping, if you have a drone at this height, then the laser is going to detect the obstacles at this height. But then so it's going to create an obstacle at this location, at this point. Let me see, because I see that there is a problem here. Okay, so looks like there is a problem here in the transmission. Let me see. Okay, so it is supposed that you can still see this. Okay, yeah, so I think that we are live again. Then we were discussing about the drone and how it creates new things at different heights. So if you are at this height, then there is, let's say, this height here. So you are detecting these obstacles. So the mapper, the cartographer, is going to provide this as an obstacle in the map. But then if you move at the same location, the robot, and then you move a little bit up, then the laser is not going to detect this obstacle. So it's going to think that the map, it doesn't have any obstacle here. So it's going to start deleting the object that has created on the previous height. So that's a problem that you have with your drone. So if you want to create a map, a 2D map with a drone, then you have to keep a certain height for that. Or the whole environment is like walls, is surrounded by walls. So it doesn't matter which height you are going to have the wall. But that's not very realistic. What I would suggest in that case is that you move to the biggest, the highest possible height. So you can capture there this whole structure of the environment without being so much bothered by the objects that are in the environment. That's my suggestion, quick suggestion for this. Okay, so then here Rishab says it was awesome, thank you. Platanecat says it's a good start introduction. Okay, yeah, so we were pretending only to do that. And then Douglas Costa says, what videos you recommend to use Slamware with ROS DS? What is Slamware? I don't know about Slamware. Let me check here on my screen. What is Slamware? Slamware. Modular solution for autonomous localization. So I don't know. Okay, so you should get, okay, so I see it's kind of a package that you can use for localization and navigation. So it's like it has integrated in the inside the SLAM algorithms. This is a board, this electronic board that you would put into your robot. Then the first thing that you need to do is to get a ROS node of this. If you want to use with ROS, then you have to create a ROS node. And I'm pretty sure that there should be a ROS node for that. If it doesn't, just check for a ROS node. It's a ROS node that connects to this to this slamware, and then it gets the data from the map of the map created or the localization, and then it publishes in some topic. So you can see that in RBS, for example. But then you need to have this node, this extra node that is in ROS. I can see here on the website that doesn't have anything related to ROS, but what I would do is to search for slamware with ROS and see if there is anyone. Here I can see a slamware SDK, yeah. So if there is no ROS node already made, then you will have to use the SDK. The SDK is the libraries that the creator of this board creates for allowing programmers to access the data. So then you need to use the SDK and create your own node of ROS that uses the SDK to communicate with the board on this side, get the data from the map, and then on the other side publishes, creates topics. So this node knows how to talk to the board and knows how to publish into topics. So basically that you will have to do to create this node. If there is none around there, you should check. So I don't know. Okay, guys, so you have this all the whole information, and I think that we have to finish here. Thank you very much for coming here. Next week we are going to talk about okay, as a surprise. So we know that, but it's a surprise for next week. So I hope to have you here today. If you want to learn about web development for ROS, waiting for you tomorrow. See you next time, next week, with more learning and more projects and more code. Until then, keep pushing your ROS learning, guys. Let me see how can I stop here, because I don't know. Always have